Hello, this is the PowerPoint called the scientific method. Now, we're going to start our discussion today by asking the question, when have you done science? And realistically, we do science anytime we solve problems. The question is, how do we do science? And the typical answer that you might hear is we do the scientific method. Now, one thing that's important to notice from this diagram is the scientific method is not a linear process. It does not go from one step to another step to the third to the fourth to the fifth steps. Notice that you can start by asking a question, you can form a hypothesis, make some observations, ask a different question, form another hypothesis, and so on. But nevertheless, there are steps of the scientific method that we typically talk about in sequential order. The first is to ask a question. The second is to gather information. Third, form a hypothesis. Fourth, do an experiment. Fifth, analyze the results. Sixth, draw conclusions. And seventh, communicate the results. These are the 7 steps. These are the 7 customary steps of the scientific method. Keep in mind, of course, that they can go in any order, determined by the researcher or the person doing the science. We're going to start though with asking a question. Ask a question is the first step of the scientific method, and essentially what you're asking is, what problem do you want to solve? The question comes from observations of the natural world, and observations are those things that are based on the senses. So it's what you see, smell, hear, taste, and feel. Of course, in science, at least in this class, we never taste anything, and generally we don't feel things either. But it's what you see, smell, hear, taste, and feel. Now, we're going to practice making some observations. It's important that observations are factual statements based on our senses. So we'll look at the first example here first. And we'll take a look at this picture of the football player. I can make some observations. Now, there are several observations that I can make. One is the word Elliot is on his helmet. Now, that's an observation because it's a fact that Elliot is on the helmet. I can also see that he is carrying a football in his left hand. I also can make the observation that his right arm is flexed. I can make the observation that there is a Reebok symbol on his right pants leg. There also appears to be a Reebok symbol on his upper left shoulder. All of these observations I can make. These are observations because they are based on my senses. They are factual statements. Now, it would be an inference to say that this person's name is Elliot. And an inference is an assumption that I'm going to be making based on observations and my own experiences. So in my experiences, it's typical for players to have their names on the front of their helmet, at least at St. John's University it is, and that's where this picture was taken. So I'm going to assume that his last name is Elliot. Now, of course, I could be wrong. Perhaps he's borrowing somebody's helmet. It's an assumption of mine. It's using my observations and carrying it to the next step. I'm also going to assume that he is running with the football because of the position of his arms and where his eyes are looking. So I can make various observations, and then I can make inferences from those observations. Now, if I go back to the example now for what a question would be. A question would be, how does fertilizer affect plant growth? In this case, fertilizer would be the independent variable. Plant growth would be the dependent variable. And we'll talk more about variables here in a little bit. The second step of the scientific method is to gather information. When you gather information, you have to ask yourself, what is the background information that will allow us to make a prediction? What do we need to know to understand the problem? And this kind of ties into the inferences I was just talking about. What do you think is happening based on your observations? Inferences involve a person's own interpretation. Okay, so based on my experiences of watching football and specifically going to St. John's, I knew that the person's last name was Elliot. That's an assumption that I've made. Okay, So an example, if I'm doing research on the question, how does fertilizer affect plant growth, I might research information on plant growth, sunlight, fertilizer, all of those different things and how they relate to plant growth. My third step is to form a hypothesis. A hypothesis is an educated guess as to what the answer to the question is. And it also proposes a reason to the problem, so you make sure you need to have that answer to the question, why. Hypotheses contain an explanation. They are based on observations and inferences. And the trick is the hypothesis has to be testable. A prediction is what you think is going to happen based on your observations and inferences. An example would be adding fertilizer to a potted plant will increase the height of the plant because fertilizer provides the nutrients a plant needs to grow successfully. And again, the prediction is that adding fertilizer to a potted plant will increase the height of the plant. That's the prediction, but I need to explain why. And the answer there is because fertilizer provides the nutrients a plant needs to grow successfully.